And basically just more general suggestions that we have, or also Mariela and Natalie will talk about their experiences taking the test, which they could talk about that as well. So again, why do you need to take the CSET? It is mandatory for a requirement for the Conventions on Teaching Credentialing. It's basically just a way of them like saying, you know what you're going to teach. So you do need to take the test or subject matter, but if you're here, probably because you have to take it. So something about the CSET scoring is you need a 220 to pass each subtest, no matter what the test. So in this case, we're talking about CSET Multiple Subject. So it is composed of English and History, which is subset 1, Math and Science, subset 2, and Human Development, Physical Education, and Visual Performing Arts is the third subset. So you need a 220 to pass each. So it's a little weird how they do actually do the score, but what they do is when you have your raw score, they convert it into an 100 to 300 point system, and then from there they determine if you pass or not by getting a 220. So it's a little weird and it's not really exact, but the way that they kind of give you kind of like what to expect is that 70% of that score is from the multiple choice, and 30% of the score is constructive response. So that's kind of it. I wonder if I should have, so this is kind of like the website, and we'll go at the very end, I'll go through it so you can kind of see and get familiar with it. So again, how to register, that's all on our website. Everything is computer-based for CSET, so you will make your account, you will answer some questions, you register through the account, you find your test day, your test location. Once you take the test, it takes about 5 weeks to get your scores. If you did not pass, you do have to wait 45 days after receiving your scores to register again. That's basically how you register and what the CSET is and how they score. So again, today we'll be talking about science and math. So again, 26 multiple choice questions for science, 26 multiple choice questions for math, and 2 constructive response for each. And we'll give you examples of what that looks like, things that you should keep in mind. Yeah, did I miss something? I don't know if anyone, Esme, Mariela, or Natalie wanted to mention something that I missed. Okay, so I think the first one we have, so these are some strategies that we, positive attitudes always come from preparation. So, we don't want you to just take the test. Obviously, one test at a time, one subtest at a time. Right now, we're focusing on math and science. Start with your strengths, something like easy to difficult, because, and Natalie and Mariela will talk about kind of like what they did to help them study. So we'll talk more about that. So this is something that I came up with, at least for the constructive response for math. And then Natalie and Mariela, you can, or even Esme, can tell me if like some of these kind of work for either science or if it worked for you. I sometimes recommend taking constructive response first or looking at it first, so you can kind of get an idea of what they will be asking you. Sometimes I hear a lot like take the test to take, or was it, I forgot that word, but it was like you use the test, and sometimes you can find similar like multiple choice questions that can help you with it. I think if you just think of the response as if you're explaining a student how to, at least for math, how you would solve the problem, that's kind of like what they look for. Be very specific, right? And asking yourself like what you did certain points or certain steps, at least for the math. So if you girls want to kind of say something of like, kind of like what other suggestions you might have for constructive response.
I would say for the math, make sure that you draw it out. So even if you don't know what you're drawing or if you're doing it right, just draw it out, because that will give you points. For example, one of my questions was trying to figure out the area of like a sink. and I had no idea what I was doing, but I drew it out. I wrote down everything that I knew. I put the dimensions on there, and I feel like that gave me a lot of points. And also, math is kind of hard to write a paragraph about, so I think it's great that they allow you to draw.
And they give you two options. Like one of the options is that you can write out your response, your explanation. You can, like, you're just explaining it in words, or you could draw it out, and then you just scan your document onto, there's a scanner, and then it uploads it to your exam. So I agree with Natalie. I definitely think just drawing it out in general, it helps you basically take apart the problem with it and figure out what it's asking you, right? So I did the same thing. I drew mine out, and then I just scanned it into the scanner, and then it uploaded to my exam. And I think for me, like for my responses, I had an algebra problem, which was my first problem, and then there's definitely going to be a geometry problem on there. So out of those two constructive responses, just expect to see a geometry problem in there. So if you're not really familiar with geometry, that would be a good area to definitely study for.
Esme, did you want to add anything?
Well, I've been analyzing the practice exams and how they also tie into the NGSS, the Next Generation Science Standards. So from what I gather is they want to see whether you understand the concepts, how can you explain it, and how can you determine any misconceptions. So are you able to decipher anything that you may think a student may wonder, and how to be able to get them to the right or the correct thinking and processing of that concept. And you two that took the test, you can let me know if I'm guiding students in the right direction.
Yeah, the math part, I think in any section, really, math or science, they're just really looking to see if you conceptually understand the problem, right? And so it kind of falls back to how we talked about, what's the purpose, the knowledge and the support for each constructive response. This still applies to science and math, even though you're drawing out the problem, but you're basically still, showing the purpose, showing the knowledge, and showing the evidence. And the same thing is going to go for the science. The science is the science, from my responses, they were all written responses. I didn't have to draw anything. So again, they're looking for the same thing in those, the knowledge, the purpose, and the evidence, which falls back onto what Esme is stating.
Yeah, and I didn't mention before, but if anyone has questions, feel free to stop us at any moment, or you feel free to also send them in the chat. I can look at the chat and I can address the question as well. So I think the first thing we'll talk about is math, and then our second thing will be science. So these are some of the domains in math. Again, I got this from the CTC website, which I can show you where I can find that. So some things like number sense, right? Numbers and relationships among numbers, algebra and functions, measurement and geometry, and statistics, data, analytics, and probability. So these are kind of like the main things that they will be asking you about. And there's like sub areas that you can look into it. I think Mariela, you mentioned this yesterday, where something that helped you was kind of like writing these down and asking yourself what each was, right? Mm-hmm. Yeah. So this is something that, again, you can find on the CTC. It's something to look at. And I also have some slides on like what kind of questions these are, like what is a number sense? Like what should I look for? And we have a couple of those. So we'll talk about that. So again, domain 1, number sense. So things you want to look into is kind of like, so these are some, right? These are not all. These are just some questions to think about. So what is a prime number? What is a geometric sequence? What is an arithmetic sequence? Place value chart, irrational versus rational numbers. So these kind of sound like a lot, but But I think understanding these is understanding number sense and kind of like what they will ask you. Real numbers, whole numbers, imaginary numbers. So these are some things that we saw that were on the test or students kind of asked us about. I don't know if you, Mariela or Natalie, wanted to add something about something that you saw in number sense as well.
I know for a fact on mine, I had a lot of knowing how to use the PEMDAS. That was like one of the most common things that I saw on my test for number sense. And then they use a lot of decimals too. Decimals, fractions, percentages. Those are all a lot of things that I came up on mine. I guess this is all kind of like what you've seen on your CBEST. It's like the CBEST touches the surface, and then the CSET and math digs into it a little bit deeper. And the cool part about the CSET and math though is that you can use a calculator. Thank God, because if I didn't have a calculator, I would have struggled. But you get to use a calculator for your CSET math exam, which was pretty helpful too. But if you don't have the basic foundations of any of the domains, you're gonna have a hard time to figure out, how to solve a problem. But yeah, those were some of the most common things I saw in my CSET exam.
Yeah. Okay. So I think one of the ones I wanted to go over, it was kind of like this question. So this is kind of one question that we've seen that students asked about. So in the expression, what does the 8 represent, right? So this is talking about place value, and I think place value is something that we learn and we kind of like just brush it off, like it goes away because of calculators and decimals. So it's something that I would say to brush, like maybe try to look into again. This is kind of something that I tell students, right? Your one space is kind of like a mirror. So this is kind of all the places, the place values that we have. And so you have like millions, hundred thousands, 10,000s, thousands, hundreds, tens, and ones. And then it goes backwards basically. So you want to look at your one space kind of like a mirror, where the difference is the tens and the tens, like the TH at the end. That's something that I kind of have seen students that help them with kind of practicing their place values. I'm not sure if you kind of can see it, but this is something that I like to tell students about place values because I think there is a lot of place value questions that come up in different forms. In this specific form, they're asking you about scientific notation, right? Or writing the 10 to the 5th power. So this is already kind of two different not subject areas, but two different questions in one. One, you have to remember place value, and two, you have to remember, so what do I do with the 10 to the 5th, right? This is not just the 8 does not just represent the tens or the hundredths place, it means something more than that. So I think a lot of the questions kind of have like a two-part to it that I have noticed. I'm not sure if Mariela or Natalie, you wanted to add something to that.
Yeah, there's a lot of kind of like I had mentioned before on other CSETs, there's a lot of correlation with other subject areas too. So this is definitely a great example that is something that could pop up on the exam. And you have to be careful because the CSETs, they kind of tend to trick you. So for example, if you don't have like enough knowledge on scientific notation and you say that the 8 is in a certain place, but you forget what 10 to the 5th power does to the whole number, it's a different answer, right? But they'll give you the answer that you think it may be, but then they'll give you the right answer. So they'll purposely try to trick you because they wanted to be able to know if you could really, or like, again, the conceptual understanding of the problem of the place value here and scientific notation. So you just have to be careful and analyze the question, what it's asking for, and make sure you understand what it is that it's asking for, because they'll easily trick you like that and give you an answer that you think is correct, but it really isn't correct. So those are just things to look up also for the math part.
I just want to emphasize on what Mariela just brought up. It's not only for the math where they try to trick you, it's for every every subtest
Yeah.
and subject. Yeah, so they'll give you like 2 or 3 answers that look like they could be it, but they're not.
Mhm.
So just be careful with that.
I particularly struggled with that in math though, because I'm the type of person in math that I solve my problem, but I sometimes don't go back and check my work. And so sometimes the answer that I got is on there. So I'm like, oh cool, like I got the answers on the choices, so that must be the answer. But then if you really check your work and you messed up what's it called, a negative sign or something like that, and it really gives you a different answer, that answer is also going to be on there. So it's just for math, for me personally, I struggled the most with that, the trickster questions. So just really pay attention to the questions that you're being asked.
Yeah, definitely. Okay, so then the next one that I wanted to go over was this one. So again, this one is it has kind of more than one type of, not one type of question, but it brings in a lot of definitions. So it says, given that figure ABCD is a parallelogram, what are the coordinates of point C? So you're trying to find for that missing coordinate. And so this brings in two kind of like subject areas. One is graphing and coordinate points, but you also have to remember what a parallelogram is, right? You have to kind of, knowing what a parallelogram is, the definition of a parallelogram, will also help you find what the missing piece is or what the missing coordinate is, right? Because a parallelogram, again, has two sets of parallel lines, which means that the line DC and AB should be the same, right? And AD and BC should also be the same. I know me talking about it like that is probably not the best way, because then you're like, what am I talking about? But again, you're taking two things in consideration for just one problem, and they will try to trick you and kind of understand, just kind of see that. I'm wondering if this one has an answer to it. So the answer is, right, C, it's 8-4. And again, it's just kind of like to think about, right? You're not just talking about graphing, you're talking also about what is a parallelogram and how will that help you to solve the problem. So just kind of like the things that I wanted to mention about these problems, and kind of like why that is important to know, just more than like just graphing. It's also knowing the geometry part of it. And then I wanted to talk about constructive response, so you can kind of see what that looks like in math. So this one actually has the question and the response, so you can see kind of what they were looking for. So this one is actually it has both kind of algebra and geometry in it. And so I think, Mariela, you mentioned, right, that for sure you'll get a geometry problem, which I've seen a lot in forms of squares or circles. I've seen that a lot as well. So they want you to use algebra and geometry to identify and explain the significance of the volume formula for a cube, as well as create a table for this relationship and graph it on a coordinate grid. Use the side measures of 1, 2, 3, and 4. And so what they did, right, they drew the cube, and like Natalie and Mariela mentioned, you are able to draw on this test if that is what you prefer, which I think visually for math, it is actually a really good thing to do, because I think it helps you kind of memorize formulas and kind of like, make relations when you draw. So again, for this one, they start with the simple thing of what is the volume of a cube, right? It starts as simple as that. Well, you know that it's the sides cubed, right? They talk a little bit about what is a cube and what represents a cube, right? They talk about the fact that the faces are squares, and squares have equal sides. So those are the little things that I always tell students, that like it sounds so like everyone knows that, but at the same time, in like when you explain your constructive responses in math, you want to say these things, because I always feel like what they're looking for is, how would you explain this to a student, right? So what are the things you would say? So again, you're not telling the student the answer, you want to guide them, so that it's kind of like guiding yourself. So like, how would you solve for it, and why did you do that? So why did you assume that the volume was that? Or how do you know that squares have equal sides? So these are kind of things that you want to think about when answering, right? Volume, they explain what volume is, right? So volume is a measurement of 3 separate dimensions, like width and height. And so that they kind of explain what the volume formula is. And it sounds so simple, something that we learned like so long ago, but that's kind of what they're looking for. They're looking for, how would you explain this to a student? And then they talk about, they made their little chart. And again, you can also draw this and scan it as well. And so what they talk about is basically like, how would they do that, and how the volume formula is growing, and how you would use the measures of 1, 2, 3, and 4. So this is kind of like, I think, one that I've seen. A lot of the other ones I've seen is talking about volume of a cylinder. I've seen that a lot. I've also seen Pythagorean theorem, and explaining that theorem and where it comes from. So those are just kind of the things that you want to think about when talking about constructive response. The one before, and I didn't go over this one, but it has actually, this one's a lot more explaining and writing than geometry. I think geometry you always draw. But this one that I have right here, this one's a lot more of explanation and less drawing. So it just kind of depends on the constructive response that you get, but I think those are the 2 different ones that you can have. I know I haven't even stopped and asked if there was any questions. If students have any questions for the math portion. And if you don't, that's fine. But that's kind of like what it is for math. And so I think math is a little bit more broad. But I think what Mariela suggested about going through the contents and domains, I think definitely helps. So you have a lot of definitions and stuff. And the good thing about math, which is a little tough though sometimes, is there's always a way to check your answers. But I think that's the hardest part, is like, how do you really check your answers? And I don't think I really talked about it, but we are offering tutoring for the math sections, and I'll be able to help you through that as well, and kind of give you more strategies and suggestions for that. But yeah, I'm not sure if you wanted to add anything else that I maybe forgot, or that you would like to tell students that you experienced during studying for the math.
For me, really quick, one thing I had mentioned before, I hadn't taken a math class in years. Given that my major, was sociology, so I didn't have to do much math. I had statistics, but it was a lot different. So one thing that I had to do for the math is I had to do practice test after practice test after practice test and after practice test, because that was the only way that I was able to get better at the domains that I was weak in. So again, I took the practice test, and I saw my strengths and I saw my weaknesses, and I tackled my weaknesses first. And I pretty much just wrote down, okay, like, this is what I need to work on, right? I'm not so strong in geometry, so let me practice geometry problems after problems after problems. And eventually, like, when I would do another practice test, I was just like, oh, okay, like, I know how to do this now, right? Because I had done it, it's the repetitiveness, right? Once you do something over and over and over again, eventually it just kind of clicks, right? But with math, it's also, you have to also conceptually understand how to solve the problem. It's not about necessarily so much memorization. It's about, identifying the problem and thinking, okay, I know how to solve this. I'm going to start this way, right? So that was one thing that I had to do with math, because that's definitely the one I struggled the most with. But other than that, I did the same thing. I set out my exam for a certain day, and I studied 2 hours every day. And I stuck to it, right? I just had to commit myself to doing that every day. And by the time that came around to take my test, I felt pretty prepared.
Natalie, I'm not sure if you wanted to add something.
Yeah, so my study strategy was very similar to Mariela. I kind of made a schedule that I told myself that I should stick to. And what I did was I took the practice test on the CTC website first, and then I went through all the questions that I got wrong, and I wrote down the topic of the question on like a little flashcard. And then the next day I was studying with Lupita. She helped me a lot with the math section, and I would just ask her questions based on the ones that I got wrong. And then for science, what I did was I just looked up the topic on YouTube and I watched video after video. My favorite one was the parts of a cell. There's a song on YouTube, and that helped me out a lot. That was actually one of my constructed responses, so I got lucky there. But yeah, just flashcards help a lot with this subtest, and just taking a lot of practice tests, that helps.
I think another thing, the last thing I want to emphasize too is the tutoring, because math for me, I think it just may be to how I learned, but I learn a lot better when I have someone physically there explaining it to me. And I know situation now may not be to where you can physically be with somebody, but even then, just like having Lupita or Alex, which was another math tutor, when they help, like it makes everything so much easier to understand. So I am personally not a person who can learn math on my own, because I need a lot of explanations because I have a lot of questions. So definitely take advantage of these math tutors that we have. They're amazing. So yeah, just that's another thing to keep in mind.
Yeah. So we'll go ahead and move on to science, which will be taken over by Esme. Just let me know what slide you want me to move into, or if you just want me to go through, that's fine.
Would I be able to share my screen?
You know what? Let me give you. I can put you
Make
as
her a co-host.
Yeah. Okay. There we go. Okay.
Yeah.
Try it now.
You have to exit out of your sharing screen to
I'll stop.
there.
There you go. Try it.
All right. Can y'all see?
Yes. We're good.
So, for the science section, there's two main parts. One is the actual content, so the knowledge, and then the second part is how to use it. So the tools and the strategies and how the science is actually used. With each of these domains, I think the most important part and like is the Natalie. Yeah, Natalie was saying flashcards, because you have to use the terminology that that is expected. And the other thing is learning diagrams. A lot of science is written in diagrams just to place a lot of information in just one general area. So knowing how to read the different diagrams, and I'll show you a few. But the content is divided into three main parts. So the physical science, the life science, and the earth science. And so within the physical science, we have chemistry, we have physics. Within the life science, we have cell biology, ecology, genetics, and evolution. Earth and space science is divided up into astronomy, geology, meteorology, and oceanography. A lot of these are very interconnected and interrelated because the whole point of science is knowing and observing and predicting how energy and matter flows. And so these are just the specifics that you can find on the CTC website in the description of this subtest. So for the chemistry portion, I think one of the most important things is knowing how to read a periodic table. And so knowing the parts of the atom and how the periodic table tells you what you're looking at. And then in physics, aside from everything that is given to you, so motion, force, just how things move, how energy can be transformed, so it cannot be created nor destroyed, but only transformed, and the different ways you can see or we observe energy, so solar, wind, chemical, electrical, magnetic, nuclear, sound, etc. And aside from that, I know I've seen a few practice problems that talk about Newton's law of motion. Would you all say that you saw that?
I had a question that had to do with that.
Yeah. So 3 main laws. One is the law of inertia. So meaning if something is in place, it wants to stay in place. And if something is moving, it wants to keep moving. Unless there's something that either from staying in place, it wants to, a force is acted upon it and then it starts moving. Or if it's moving, a force is acted upon it to stop it. So a car hitting a wall, right? That force would be the wall, and the car, instead of it's no longer moving, but it's now stopping. So that's the law of inertia. The law of force is just with a similar force, something heavy is going to be isn't going to move as far as something light. So the baseball batter, if he uses the same force in the swing, that the baseball is going to go a lot further than a bowling ball, just because this is a lot smaller, a lot less massive than something that is more massive. And then the law of equal and opposite reaction, it just is saying that whatever force you place upon something, that force is going to place upon you as well, with the equal magnitude.
I have a comment
Yes.
about Newton's laws. So you won't only see this on subtest 2, but you'll also see it in subtest 3 in the physical education portion. So just be sure to familiarize yourself with the Newton's laws.
Alrighty. And so life science, in cell biology, knowing that a cell is the smallest unit of life, just the different types of systems and how they're organized. Would you say that you had to study different types of systems within the body? So like maybe the digestive system or the cardiovascular system. So although it's not detailed here, knowing what are the different systems in the body and how they're organized from the cell level to the actual organ system. Right here, nervous system, reproductive, circulatory, and then how DNA works. And in biology, especially, carbon is one of the most essential elements, mainly because it makes up who we are. We are made of a lot of carbon, and it's what we breathe out, it's what we eat, in our sugars, in our carbohydrates, in our fats, all of that is made of carbon. So then it's how do you use that in energy? And then in the opposite, the energetics of photosynthesis, how do trees convert carbon dioxide into the energy that we eat, or plants in general. Ecology is mainly about the ecosystem. What do things need to survive? Food, water, space / shelter. Adaptation versus accommodation. So it's adaptation is a whole species, whereas accommodation is the individual. So it's like we have adapted opposable thumbs, whereas accommodation is if you come from Texas and then you move to Canada, you eventually, after a few years, get used to the cold. And then genetics and evolution, how do traits pass down, and how are different traits used in survival so that they pass down to the next generation? And how do we know? What do we use as evidence for evolution and the evolutionary theory? Anything to add for that section? And a lot of videos explaining each and every one of those helps, as well as I would say flashcards, just to familiarize yourself with the language. And then in Earth and Space Science, I think this one is the one where you're most going to use diagrams. I forgot to mention that in ecology, the food chains, those are usually, and then the cycles are usually diagrams. So being able to read and understand the diagrams and how things move would be beneficial. And then Earth and Space Science, a lot of diagrams. So astronomy is how are the planets moving, and the orbits of the sun and the moon. And so how it relates to weather and how it relates to our seasons, how it relates to time in different parts of the world, how it relates to the different phases of moon that we see. And then these are just like the different speeds of the orbits. How is one day on Earth compared to one day on Mars? Geology, I think there's a lot, I've seen a lot of practice problems on geology. I don't know if a good majority of the exam, you see geology questions. But these go through, I think one of the biggest things is, what is Earth composed of? How do tectonic plates play a role in what happens to our Earth? So earthquakes, faults, and how does it affect society? And then meteorology is just weather. How do we see weather patterns? And how do high temperature and low temperature affect how the weather is going to be? And how just basically heat moves around the Earth. So it can either travel through air or travel through water. And then oceanography would just be, how do these different bodies of water act and react depending on what we see. So I think one of the things that we may see is about tides. So how does the moon affect the tides, and also the water cycle. And then the applications of it, it's basically, can you develop a problem or solution if you need to, using the knowledge? So how can we develop different technologies or assess the efficiency of different technologies that we currently have? That's basically what it is. Any input?
I know a lot of the diagrams that Esme mentioned do pop up on multiple choice and written response, so it is important to be familiar with those. I got mine on the life cycle of a frog, and it had it had the explanation in a picture, and then I had to explain it myself. But I also had some during the multiple choice questions, so definitely familiarize yourself with the most common ones that are known in science.
One of the most common ones is primary consumer, secondary consumer, that little diagram where it kind of looks like a pyramid of rectangles. I don't know.
Yeah,
I don't know
so
if you included that one.
in that would be ecology, and that's the sorry, right here, the transfer and cycle of
Yeah.
energy and matter. So how does energy move through the ecosystem?
That one pops up for sure.
Mhm.
Okay. I don't know if anyone has any questions that would you would like to ask us. Again, we have our email. I'm not sure if Esme you have that slide, or I'll share it with our with this one. Yeah. Let me put up. Is it no? Where did it go? Oh, I don't have it up. Let me. I think I lost it. Let me open up again. Okay. I'm sorry. Okay, so let me share my screen again. So there we go. So again, that's our email. It's just eq@csus.edu. So feel free to email us any questions. I think I've mentioned this before in other ones, but you can just send us pictures of the questions that you have, or you can just set up an appointment with one of us. So I'll be doing the math in this, and Esme will be doing the science. But again, Natalie and Mariela have taken this test, so I'm pretty sure they can kind of give you more strategies on how to do it. I know Natalie talks about YouTube videos a lot, so looking at that. So if you haven't really started looking at it, I think the CTC exam website is probably one of the best. You want to get familiar with it because you'll be registering through it. Get familiar with the practices they have there, and then go ahead and email us with any questions. Do you agree with me, Mariela and Natalie? I don't know if you wanted to add something else.
That sounds about good.
Yeah. So I think I'll go ahead and I'll stop recording. If anyone has any more questions, again, feel free to email us. Again, tomorrow we'll be doing subset 3. So we'll all be here again. So if you can join us, we'll see you tomorrow. Okay. Have a great day, everyone. Thank you for coming. Bye.